Welcome to this video. In this video, we are going to study phosphorus analysis as part of one of the analysis that is done to determine the available phosphorus in the soil. Now, the reason for doing this kind of analysis is to determine the amount of phosphorus in the soil and to determine how much to supplement for plants with. If we realize that the phosphorus available in the soil is so down that we won't even be able to supplement or it won't be able to help the growth of plants, then we have to add more through the application of fertilizer, phosphate fertilizers in the likes. Now, let's look at this question. In the laboratory analysis of available phosphorus of a soil, 5 grams of the soil was extracted with 20 ml of dilute acid fluoride solution. The figure below indicates the standard curve obtained by plotting percent transmission against concentration. Now, you realize that before we determine the phosphorus content, we have an instrument that is used to do that. It's called the spectrophotometer. Okay, spectral because it's about light. Okay, and I mean, a spectrum, it measures the spectrum, and then the photometer measures light, the intensity of light. Okay, so spectrophotometer is the instrument that is usually used for determining the available phosphorus by measuring the transmission. Okay, so over here, the transmission will be plotted against the concentration of the phosphorus, in the soil. Now, we use the extractant called dilute acid fluoride. Okay, it's an extractant that is used to extract the available phosphorus within the soil. Now, in this analysis or experiment, 5 grams of soil was used, and the extractant that was used, the volume was 20 mils. Now, let's move on with the question. Now, this curve was said earlier to have been, it was spoken earlier about. So over here, the y-axis is for the transmission, that is 2 minus log t, and then the x-axis, that is the 0.246. They represent the concentrations of the phosphorus in micrograms per milliliter. And you can see up there we have y equals 0.012x. That is the equation of the line. Okay, it's a straight line. So the straight line, the equation is y equals 0.012x, where the 0.012 represent the slope because the coefficient of the x is always the slope of the line. In other words, if you have to take a first derivative of that line, it becomes 0.012. All right, now let's move on. Now, this also an additional information that was provided by the question. Uh, we are to we were given that the soil extract, okay, the transmission of the soil extract was 80%, and then the blank is just a solution without the soil, okay, which was used it was passed through the same process, okay, and then the acid was added and everything. Then the the transmission was measured by the use of the spectrophotometer, and we realized that the transmission was 100%. Now, we have to calculate the available phosphorus content of the soil extracts in micrograms per milliliter, in micrograms per grams, in milligrams per kilograms, in pounds per acre, and also in kilograms per hectare. Now, let's start by tackling the very first one. Now, available phosphorus content of the soil extract in micrograms per milliliter. You realize that in the equation, in the graph, we have the y to be the transmission and the s to be concentration of the phosphorus content, which is measured in micrograms per milliliter. So you could see that if you have the different y values and also you have the different s values, you could determine the concentration at that particular point where we want to determine the phosphorus content. Now, from this equation, y equals 0.012x. The 0.012 I said earlier is the slope of the line. Now, to determine um, the phosphorus content, you see that the x is what is representing the phosphorus content in the micrograms per milliliter, and then the y is the transmission. So if you need x, then we have to make x the subject, okay, by dividing both sides by the 0.012. So that's what will be done here. So we divide this is the equation y equals mx, where the y is the 2 minus log percentage t, and then m, the slope, times the concentration, that is the x. Okay, so if you need the concentration, then we have to divide both sides by m. Okay, so concentration becomes 2 minus log t divided by m. Then 2 minus log t, we were given t in the table to be the soil extract. The t of the soil extract was 8%. So in this case, we have the concentration to be equal to 2 minus log AT divided by m, which is the slope of the line. Remember, it's 0.012. So we have this. So in the end, our concentration of phosphorus in micrograms per mils becomes 8.08. Then we move on to the next question. We have to determine the phosphorus content of the soil in micrograms per grams. Now, in this case, we want to measure it in terms of a gram of soil. So if you take 1 gram of soil, how much content or how much phosphorus is in there? Okay, before we could do that, we have to multiply the concentration of the phosphorus in the soil extract, okay, times the volume of the extractant, then we divide it by the mass of the soil. So we are determining the concentration in terms of the mass of the soil. So you first calculate the ratio of the volume of the extractant and the mass of the soil. Then we multiply it by the concentration that we calculated earlier. So that is the formula. So first we determine the concentration of the phosphorus in soil extract, which was determined in the question 1, okay, to be the 8.08 micrograms per mils. Then the volume of the extractant was given in the question to be 20 mils. Okay. And then the mass of the soil that was used for the experiment was 5 grams. Now, in some cases, we could use different volumes or different volumes of the extractants and then different masses of the soil. So you always have to pay attention to the volume of the extractant that was used and then the mass, okay, of the soil. So you could do that easily. Okay. So inputting those values, we have 8.08 micrograms per mils to be multiplied by the 20 mils divided by 5 grams. Now we end up getting 32.32. Now, looking at the units, the very first one is micrograms per mils. Okay, micrograms over mils times mils over grams. So mil and mil will cancel out, leaving the micrograms per grams as the unit of the concentration. Okay, as we are asked to calculate. Now, in the third question, we have to calculate the available phosphorus content in milligrams per kilograms. Now, this expression here shows that the parts per million is the same as micrograms per grams, and it's also the same as milligrams per kilograms. It means that if I have any value of any quantity in parts per million, that value will be the same in micrograms per grams, and it will also be the same in milligrams per kilograms. So in the earlier question, we calculated the phosphorus content, which was in micrograms per grams, okay, to be 32.32 micrograms per grams. So to calculate the content of phosphorus in milligrams per kilogram, since they are the same, then it's going to be the same thing. So the available phosphorus content is going to be 32.32 milligrams per kilograms. And move on to the last, the last but one, the available phosphorus content of the soil in pounds per acre furrow slice. Now we want to calculate the phosphorus content in pounds per acre. Realize that this unit, pounds per acre, is more or less like a unit of yield. Okay, but then it's used, field. It's a field listing because we are looking at acre, that is the area of land, and then also the pounds, that is mass. Okay, so pounds is also a smaller unit of mass. Now, there's this assumption that we use to do this calculation. Okay, we understand that the parts per million, okay, if you multiply we double the parts per million, you always get pounds per acre. Okay, so to get pounds per acre, we always have to multiply whatever value we have in parts per million by 2 to get the pounds per acre. Okay, I've done a video on how to do these calculations or these conversions. I encourage you watch the videos to get a better understanding of this. So pounds per acre equals 2 times parts per million, where parts per million is the same as micrograms per grams and also the same as milligrams per kilograms. So as calculated earlier, parts per million will also be the same as 32.32 because over here we said that they are all the same. So in that case, we have the pounds per acre to be 2 times 32.32. which is 64.64 pounds per acre. And move on to the last aspect. We have to calculate the available phosphorus content of soil in kilograms per hectare. And there is a direct relationship between pounds per acre and kilograms per hectare. They are all units of yield. If that's what the agronomists will say, they are units of yield because they compare the mass, the quantity, okay, to the area of land or whatever. So pounds per acre, whenever you have the value in pounds per acre, you want to get it in kilograms per hectare. Just multiply it by the conversion factor 1.12. So 1.12 times the value in pounds per acre will always give us the value in kilograms per hectare. So 1.12 times pounds per acre equals the value in kilograms per hectare. Now, earlier we calculated the value to be, the value of the phosphorus content in pounds per acre to be 64.64 pounds per acre. So to get the value in kilograms per hectare, just multiply that value by 1.12. Okay. In other words, um, it works in the other direction as well. If you want to calculate for pounds per acre, given the kilograms per hectare, then if you know kilograms per hectare and you are looking for pounds per acre, then you have to make pounds per acre the subject of this equation by dividing both sides by 1.12. Okay, so pounds per acre will be equal to kilograms per hectare divided by 1.12. So whatever value it is, you divide it by 1.12, you get the value in pounds per acre. And in this case, we have to calculate the value of kilograms per hectare from pounds per acre. So we just have to multiply the value in pounds per acre by 1.12. As simple as that. All right. So we'll be able to get the answers to all our questions, and this marks the end of our video. Thank you so much for watching. Subscribe to my video, like, comment, and share.